All right, let's get started. So I have to start by ranting just a little bit about Piazza. When you post anonymously, just to make sure everybody knows, you're not anonymous to instructors. It says posted anonymously, but here's their real name. So what am I doing? So it makes it difficult to open up Piazza during lecture. So I have to write some JavaScript to remove all of your names so I can actually open up Piazza during lecture, which seems like a pretty common use case. You want to show Piazza post during lecture. You can't do that while respecting anonymity. So I have to write nothing complex, but like non-computer science professors might take a bit to find that. To remove, I'm just doing something simple. I'm removing all of these spans from the page because your name is included in a span. Someday I'll have to write that a little better and put it in a browser extension, but things we have to do. Anyway, so next week we have the 2 review lectures, but today, the rest of this week is kind of review lectures too. Today and Friday are review lectures about LO3 content, so any LO3 things that are in here, I'm going to start picking from this for today and tomorrow, and go off of that. So in the previous lecture, unless things have changed a lot, graphs was the number 1 voted thing, which is fine. We did it in the previous lecture, but y'all gave me 1 word to work with, and I got to fill 50 minutes. So I'm just going to do graph stuff. I'm going to do live coding with graphs and try to make it relatable to the homework. I shouldn't say try. I'm going to make it relatable to the homework. So hopefully it helps you get started with that. But I'm pretty open to what we end up doing this week. I say within reason here, but that within reason is pretty wide open. Like, it doesn't even have to be material related to the course. Every suggestion so far has been related to the course. There's 1 new one I'm excited to see that I haven't looked at yet. So maybe that'll change. But it's whatever y'all want to see. So if you do just want to see everything about graphs, that's fine. Yeah. I'm not doing memory diagrams for graphs. Unless it's upvoted, there is a post on here, memory diagram of graphs. It's not something I've done, and it's not going to be on the quiz. Yeah. Only linked lists and trees on the quiz. So since I haven't covered it, I'm definitely not putting it on the quiz. But if this gets enough upvotes, hey, I'll do memory diagrams with graphs. 1 issue with that is I've purposely never done a memory diagram with a map on it, and with a graph we have to have multiple maps. So we got to start by saying this is how we put maps on the memory diagram, which isn't too complex. It's pretty simple, pretty straightforward. But it's another thing we have to do. That's why it's not on the quiz, because I didn't want to throw maps at you right at the last second, and I decided to not do it earlier in the class. But if this gets enough traction, I'm happy to do it. But I'm done with content. There's nothing more that I need to present to you, need to convey to you. And especially these last few weeks, as you can tell, the crowd's going to thin out. It'll probably thin out a little bit more as well. We can get a little more personal with this. I want to know what those of you who are still coming to lecture want to see. I can, if it's it's whatever y'all want to see. You got me here, open-ended, whatever you want me to show you. If you want me to give you a preview of 250 or 331 even, I don't know, whatever y'all want to see. But let me go down this list just to talk about each one that's been voted. Graphs by far getting the most traction, but again, 1 word. If you can give me more details on these and guide me a little more, I'm happy to just say everything about graphs, but I did that in the previous lecture, and they seemed pretty non-interested. They were all started to talk to each other and stuff. Give me more to go off of if that's what you want to see. Otherwise, I just have to guess at what I think you want to see, and I'm not always right. Binary search, I'm happy to do that. It's getting some traction. Binary search with trees. This is another thing that's not on the... Oh, I've never said that in lecture. Let me not finish that sentence. But I'd be happy to go over that as well. It's getting some traction, so that might be the next thing. The first thing that we talk about next Wednesday. No, that's still LO3 content. Maybe I can talk about binary trees on Friday. But again, I don't know what to talk about. I already talked about... Oh, this says binary search. I'm just reading it wrong. Oh, yeah. I'd be happy to go through binary search. This isn't even binary trees. Oh, yeah. Yeah, I'll do that. is the second most voted thing. So maybe I'll do that on Friday. Runtime optimization, go over types of, and again, this got a little more traction since the last lecture. It only had 1 vote last time, so it's getting up to 3. Maybe this is something I'll end up covering. Lab quiz review memory diagrams, lab quiz review memory diagrams. Somebody wanted to post it twice, make sure I heard it. 6 and 4, getting a little bit of traction, but I mean, this is Monday's lecture. Monday's lecture is already on the schedule, guaranteed I'm going to do this. So you didn't really have to vote for that one, but this will be covered regardless on Monday. I'm not going to do it before Monday because we're in the middle of quizzes, and I don't want it where parts of the class got the review before the quiz and parts didn't. It's just not fair. I'm going to do it Monday because it's exactly in between everybody taking the first round and everybody taking the second round. So Monday is the day that has to be, in the spirit of fairness. Memory diagram of graphs, again, if this gets more traction, be happy to do it. It will take a whole lecture to do a memory diagram with a graph, though. But it's got to get more traction. Tips for the LO3 interview quiz, which I'm a little surprised that hasn't gotten more traction, but again, that'll be Monday. Runtime optimization, again, like the other runtime stuff, didn't get much traction, but I'd be actually happy to do runtime. It's like the next thing, like it's where 116 kind of stops. We flirt with the idea of optimization and runtime, but never really go diving into it. So it'd be fun to like kind of do the natural next thing, which is 250 territory. It is literally the next thing you're going to learn besides 220 stuff. So I'd be happy to, but if it doesn't get more votes, of course not. And the last one I haven't read yet, this one I did read actually. Objects and classes in Python, I'd be really happy to do this. I believe this was very highly voted last semester. It was highly voted enough that I devoted, I think, 2 lectures to it because there's a lot of traction for it. So pretty much going over a lot of 116 content, but in Python, and just doing a lot of live coding with Python. I like doing that. I think it's fun. I think it's very useful because you're probably not going to use Scala again, like outside of being forced to. Like in 250, you'll use it again, and then probably not again after that, unfortunately. But you will use Python a lot. And I have, like, I'll talk to a lot of higher level students, like my TAs and stuff, and students in 312, and they'll be using Python and have absolutely no idea how to do OOP in Python. So we spend all this time in 116 teaching you OOP, and then I just assume those skills will transfer over. You'll be able to do OOP in Python, and it just doesn't happen that way for a lot of students. So I think we might, some official instruction, and like this is how you take all this content and use it in a language that you're going to use more often in the future can be very helpful. So I'm glad this is getting traction. This is just posted during the last lecture, and it's already getting a lot of stuff. So this one I haven't read. Recursion more in depth than practical uses. We're up to. I try. Piazza should just have an option to hide I'm glad, but I still want to. I want to be respectful of anonymity, though. But recursion more in depth than practical uses. That'd be fun too. Hope that gets more traction. But that's where we're at. It looks like classes in Python is gaining steam really quick. So that is the new number 2. And then binary search got knocked down to number 3. And graphs today. So probably graphs today, binary search Friday. I can't do Python this week because it's not LO3 related. But then next week, probably Wednesday, do Python, barring any big changes in here. So if there are things that you would like to see, get your posts on here, get voting on things, make a post and then advertise your posts and try to get people to vote for it if it's something you really want, whatever you want to do. But I'll keep checking this. I take this post really seriously. This is what I'll do the next few weeks. These are the 2 weeks where I don't have, I already did everything I need you to know. Now's your time to just get whatever you want to see. Okay, with all that said, get into IntelliJ and do some stuff. Organize this a little bit. For section A and section B. We'll start from scratch. So I'm just going to do some live coding with graphs. And just show you how to use this graph class. It's one of the pieces, like I got one word to go off of graph, and I think it's one of the only pieces that I haven't really shown you too explicitly is how to use this graph class. In lecture, we went through breadth first search and how to use that for distance and pathfinding and everything conceptually, and showed you some of the homework code, the handout code, but bridging that gap, how do I use this graph class? So let's do that. And since we're in like a review portion of the class, whenever I see like a programming tip or trick or something, I'll spend a few seconds to talk about it. So one, if you haven't seen this one yet, you want to write a main method, just type main and hit enter in IntelliJ. And whenever I'm writing some code, you need a main method because you need to start in a main method. And actually, this isn't going to let me run. I have no green arrow or anything. You can only have a main method in an object. So I have an object, now I can run my method, main method. And it's generally good practice to not put much code in your main method itself. You want to immediately defer to some other method, something else that's going to be running your code. So I'll create an example method. It's going to take nothing, return unit. It's just where all of my stuff is going to go. And then the main method is just going to call example. So any code inside your main method, you can only execute that code by running your, program. Which is fine if that's all you want to do is run that code and that's it. But sometime down the road, you might change your mind and say, oh, I want to run that code multiple times, or I want to take this portion of my main method and run it 3 times, or something like that. In this, I was trying to come up with a good example in the previous lecture. Best I got is if I want to do runtime analysis on my example, on my method, I want to see how efficient this is in absolute terms, not in asymptotic terms, and I run example and it takes 0 milliseconds. Doesn't give me any good information at all. I might want to run example in a loop, like 1,000 times, take the runtime of running 1,000 times, then divide that by 1,000. Might give me an actual meaningful number that's large enough to actually work with, instead of just rounding down to 0. So that's one case that, in this example, I might want to run this more than one time. But depending on your code, there could be many, many different reasons. You want to run the code more than once. So by habit, I typically put very little code in my main method and just defer to another method. And you can see this throughout the examples repo. So what we want to do is work with this graph class. Graph class has 2 maps. One map that maps IDs to node values. And then the adjacency list, which is a map that maps IDs to a list of the neighboring IDs. So let's hammer this down a bit more to see what exactly is happening here. And I'm going to get a little on the nose when it comes to the homework. I'm going to create a class called grid location. Grid location is going to have x int and a y int. That is literally the grid location class, right? But I made them vals. Center as vector, which is something you don't have to use. ToString is nice. Equal. Okay. Equal is nice to have, but not required. But the constructor is really what we need, is an x and a y. I might as well make them vals just for consistency. And then in my graph example, I'm going to need a new graph, which I'm going to call graph of type graph equals new graph. And I'm going to get errors here already because I didn't import graph. So this is one of the cases, this is one of the common mistakes, not just from students, but in programming in general, is importing the wrong class. When I try to import this, I'm going to get multiple choices because graph is such a common class name in programming. There are a lot of instances where somebody wants to use the name graph. So I have a couple. This library here, which I don't know how to pronounce, GrailVM maybe, I don't know. It has a class named graph. Sun has a class named graph, and then of course the one that we want, the one in LO3 data structures graph. If I import the wrong one, I'm not going to get what I want. It's not going to have the methods I want. It's not going to be built with a map of nodes and an adjacency list. It's not going to be that kind of a graph. We can take a look at the code. It's Java code, has a type parameter, and it does actually have nodes and edges, but it's edges and not adjacency list. But it's the same idea. We have nodes as the type parameter, and then an adjacency list, which is the type parameter to a set of type parameter. We use a list. It's two data structures doing the same thing in this case. A set would be fine for our purposes. And then it does the same thing, but you're not going to get dot adjacency lists. Like, it's just not going to work in our code. Unless you actually code to this. If you got to use the type parameter instead of IDs, which gets a little more tricky. You don't have to deal with this whole idea that each node has a unique integer ID. If that's confusing you, hey, grab this one and use this one. I ain't going to stop you. That works directly with the type parameters. I think this way is a bit more confusing, which is why I didn't set it up this way. But that graph isn't going to be the one we want. Let's delete that. Try again. Make sure we get the one that we want. So that's a fairly common and pretty simple office hour questions. It's like a 2-second visit. As long as we see it, sometimes me and the TAs, we don't see it right away. But as long as we see it right away, we'll look at your imports and say, you got the wrong import there. And you go, dang it. And then you get the right import, and you're on your way with the homework. I'm also going to get an error. I'm going to get an error still because I don't have a type parameter for my graph. And I want to create this as a graph of grid locations. So I'm going to do grid location. The type is inferred on the right, but I could add it if I wanted to. I can also add my empty parameter list if I want to. I'm going to create a graph of grid location. Now notice I didn't have to import grid location. I just used it. With grid location, it's located in the same package as the code that I'm writing. So anything in the same package is automatically imported. You don't have to explicitly import any classes or objects that are in the same package as the code that you're writing. So I didn't have to worry about that. But if it wasn't, if I didn't have grid location here, there's no other one. In the other lecture, I called this point. Well, let me make that change. I used point in the other lecture. And point, there are all kinds of classes. Point is a very common name to use. There are lots of libraries that have a point class. They're all in different packages, but we need to import the right one if we're using that. But we're using grid location, so we don't have that issue. Oh, yeah, thank you, because I commented it out. I'm like, why am I not getting autocomplete? It's making me type the whole thing. So we have our graph of grid location, and then we want to start using this thing. So we have two main methods that we'll use in our graph, add node and add edge. That's going to populate this graph with all the information that we want it to have. I have a few other methods, is connected, is path. These used to be tasks on the homework, but aren't anymore. Well, distance is, I guess. But add node and add edge are the two big ones that we want to use to create a graph. Where am I? Graph example, close others. So let's add some nodes first. To add an edge, you have to already have added the nodes. So let's add the edges, graph.add node. Did I say edges? And for each node that we add, we need to give it a unique ID. You have to have a unique ID for each one. Simplest thing to do is to start at 0 and just increment by 1 each time you add one. So I'm going to start at 0 and do new grid location of 2, 5. Then I'm just going to add some points here. 2, 5, 2, 6, 2, 4, 3, 4, 4, 3, 4. I'm already having trouble visualizing. And at this point, I was going to create all my nodes first, but I don't feel like using my brain more than I have to. I'm going to start visualizing this. This is the graph we had in the other lecture, so let's duplicate this. Don't judge me for renaming this sheet 4. I just don't like seeing that copy of. Delete. Fill, reset. And let's visualize this thing. 2, 5 is where point 0 is. 2, 6 is where 1 is. 2, 4 is where 2 is. 3, 4 is where 3 is. And I want 4 to be right here. 4 is going to be at 3, 5. So notice when I came up with these integer IDs, and this would be and everything else would be walls. So notice when I come up with these integer IDs, I just made up IDs for each one. The only thing that's required for these is that the ID is unique. I can't have 2 nodes with the same ID. As long as that's the case, this graph class is going to work just fine. These can be completely out of order. Now for the homework, there is meaning to the IDs because they're generated using a formula to make sure to guarantee that no 2 grid locations will have the same ID. But it doesn't have to be that case. I could just use random values. As long as I don't have any duplicates, everything's going to be fine. And at this point, done. I want to run this in the debugger and take a look at what this graph actually looks like in memory. How did I do the auto formatting thing? I'm glad you asked, but we did talk about this last time too. I'm happy to talk about it again. On my Mac, it's Command Option L. So I've been getting, with modern tools, as developers, we tend to get lazier and lazier the more tools that come out, or at least I do. So I'll be very sloppy when I'm typing my code. You usually notice that. And then I'll hit Command Option L, and it'll auto-format and make everything nice and pretty. So I'll just type really sloppy and then do auto-format all the time. Instead of, back in my day, we used to actually have to focus on writing our code nice and neat and everything. These days, we got tools to do that for us, so screw it. I don't remember what the shortcut is on Mac, but if you go into the IntelliJ preferences, you can find a list of all of the keyboard shortcuts and whatever the one is for auto formatter. So let's take a look at this in the debugger. See what we got. It's one of the most handy shortcuts. That and control clicking or command click on Mac. You saw me just do that. I didn't really highlight it. But let's get this debugger running first. If you command click on something, it'll take you to its definition. So like when you see me going into the Scala libraries and the Java libraries, all I did was command click. You want to see what the int class is? Command or control click on it. And it'll take you to its definition. Here's the definition of the int class. It extends any val like we expect. It's got a bunch of conversion methods. The operators, addition, subtraction, which doesn't have any code defined, a deprecated plus method, because it's a unary plus now. Well, the actual code. Never looked at the int class before, but all the operations and stuff. But command click, very handy. Also, those are probably my two favorite shortcuts, besides things like Control D. So you know Control C, Control V, you can cut and paste, of course. But if you highlight in IntelliJ, these are all IntelliJ things. In IntelliJ, if you just do Control D, it'll just duplicate whatever you have highlighted. So you can create copies of code without muddying up your clipboard. Sometimes I care about what's in my clipboard. I want it to stay there. So Control D lets me cut and paste, create a copy of something without using my clipboard. So I think that one's really handy too. I use that one all the time as well. So we didn't run what we wanted to, which is a common thing. A lot of you have heard me say this before. Whenever you use these buttons up here, it runs the last thing that you ran. It doesn't run the file that you currently have open. So that's what happened there. And I actually got an error because the last thing I ran was the code that I typed in the previous lecture just an hour ago. And I moved that. You saw me move that at the beginning of this lecture, so that file doesn't exist anymore in the location that it used to exist in. So I got to click here and go to debug, and that's going to run this code. So I set my break, I ran the debugger. We can see the main method called example, and in example, we hit my breakpoint, which I added a do nothing line here just so I could set a breakpoint. You can't set a breakpoint where there's no code, which I think you should be able to, but whatever. I'll just add dummy lines to set my breakpoints. And we set this breakpoint after the graph was completely made. Let's take a look at what we have in here. So first, the adjacency list. We expect this to be empty. We have an empty list for every node because we didn't add any edges. So we expect our adjacency list to be empty, and it is. But let's take a look at what nodes is, because this data structure is complete. So with nodes, we're mapping each node ID to the actual point at that ID. So the node with ID 0 is mapping to a grid location 2, 5. I got a grid location, some spot on the heap at 2, 5. They're in order for some reason. Just happen to be in order? That wouldn't make sense. The ID 2 is in 2, 4. So there's no order to maps. There's no meaningful order. So it's weird that I have all these nodes in order. I swear they weren't like that in the previous lecture, like just not long ago. Is it possible that we just got randomly in order? 3 is mapping to 3, 4. So we can see for each ID, these arbitrary IDs that we assign to the nodes, this map is telling us which ID relates to which actual value. So that's what this data structure is doing, this nodes data structure. To be honest, for your homework, you probably won't touch that data structure. But if you do, if you have an ID and you want to check which node it refers to, that's your data structure. That's the one that you're looking up. You're saying, hey, nodes, I have this ID. Give me the actual grid location for that ID. That's what that one's doing. But what we're really interested in is adding edges. So we want to add some edges to this thing. I'm going to use my visual cheat sheet here. And I want to add edges between any valid moves in this graph. So I want to add an edge, and we do this by ID. So at this point, like, we care about these grid locations. I care what these grid locations are. We're going to use this map to visualize the grid locations. But in the code no longer cares about grid locations at all. The code only cares about the integer IDs. So when I'm adding these edges, I'm adding them by ID. So there's an edge between 1 and 0. I'll start at the bottom left here. Between 0 and 2. 0 and 4. And by the way, where I'm defining edge the way we do in the homework, where it's a valid move for the player. between 2 and 3, and between 3 and 4. And the order doesn't matter here. If I do 2, 0, or 0, 2, it's going to give me the same effect, because in the graph class, adding an edge adds the edge in both directions to the adjacency list for both those nodes. So it doesn't matter which order, it's going to do the same thing. So I have those edges, and now that is all of them, right? 1, 2, 3, 4, 5 edges in the graph, 5 edges. And now let's run this in the debugger again and see what our graph looks like now. Our nodes data structure, we don't expect that to change at all, but let's take a look at our adjacency list and see what format that is in, what it looks like. So the adjacency list, yeah, this is all in order too. What's going on today? So the adjacency list is going to tell me all of the neighbors of each node. So it's going to map 1. 1 is the key. It's going to map to all of the neighbors of 1, which in our case is all the valid moves that a player can take if they're at node 1. So the list has size 1 and contains just the value 0, exactly how we would expect it to work. If we look at the value, the node 0, so 0 is going to give me 4, 2, and 1. 4, 2, and 1 are the valid moves that I can take from node 0. So the adjacency list is giving me exactly this information. So when I'm running breadth first search, I go to this adjacency list, say, give me the neighbors of this node, and do your thing with those neighbors. Okay, give me the neighbors of this node, then do your thing with all the neighbors. But you're going to the adjacency list to do that. And in fact, in the code, which I think is a little bit of the disconnect, so I want to dispel that one right now. I'm just going to go to graph.adjacency list of 0. Oops, 0. Run this not in the debugger. Could have ran it in the debugger, I guess. That's going to give me that list 4, 2, 1. So if I want to check all of the neighbors of node 0, I'm going to go to the graph. I'm going to say, give me your adjacency list, and give me the value at the key 0. And that's going to give me all the neighbors of node 0. If I want to take this a step further, let's say I want to run breadth first search, and I'm starting at node 0. This is a hypothetical. I'm not going to give breadth first search code, but I guess a little bit of it. Neighbors of start ID equals 0. It's going to be a list int. Wait. I answered a question wrong after the previous lecture. Oopsie. And then we can go for ID in neighbors of start. And say I want to check the neighbors of the start node. Now for your homework, you do this in a loop and check the neighbors and the neighbors and the neighbors and the neighbors and keep exploring. But if I just want to check the neighbors of the start, I'm just going to cut and paste this code. The neighbors ID. So I want to get the ID of each neighbor, get their neighbors, and then for ID of neighbors, let me not do that. Let me just print line. That's what I want to do. Print line the neighbors of ID are neighbors. So I'm getting all the neighbors of the start ID. I'm iterating through all of the neighbors of the start ID, getting all of their neighbors, and then printing out what their neighbors are. I run this code. My start ID is 0, so I should get the neighbors of 2 being 0 and 3, the neighbors of 4 being 0 and 3, and the neighbors of 1 being just 0. This is exactly what I get. So I'm iterating over the neighbors of the neighbors. I'm checking the neighbors of the neighbors of the start node. And this is the idea. You would expand this into breadth first search. But you're just going to your adjacency list and talking to your adjacency list, saying, hey, graph, give me the adjacency list and give me the neighbors of this node with this particular ID, and then using that information over and over to run through breadth first search. But you go to this adjacency list directly. Just say, adjacency list, give me your information. Anyone have questions? The other lecture didn't have any questions, like the whole lecture. They had 1 or 2, but if that's going to be the case, I'm just going to keep barreling through. Because I did a standoff with them and made them ask a question, but I don't want to do that again. So anyone have questions? Going once, going twice? Yes. Yeah. Yes. Yes, there absolutely is an easier way, but that way works. Like, I mean, if it works, it works. So the easier way would be, let me actually do that in here. The neighbors of, you would go, this is where you do, so your short answer, this is where you'd use the nodes map. So if I want to say graph.nodes of ID, which I don't have a toString, so this is going to print out pretty bad. We slap a toString in here real quick. Override toString. I won't use my fancy formatting I used in the homework code. X, Y, plus, oh, you got a comma in there. I had a comma instead of a plus. Run this again. So if you go to that node's data structure, that's going to take an ID and give you back the original value, the actual value for that ID. So you can do that in that map lookup. So I would go to that map and say, okay, what's my point? So the point at, I can't even tell which one it is. It's either 4 or 2. So the ID at, well, no, I do know. 3, 5. I'm looking at the edges. 3, 5, there we go, is 4. So this was ID 4, and I went to that data structure and said, what's the grid location with ID 4? And it said, that's 3, 5. And yeah, you do, I said several times you don't need that node data structure, but for the application objective, you will want to use that. Or you could do it the other way that you said. You can actually do it mathematically. This is actually the next point I want to jump to. You can actually do it, reverse it mathematically. So let's, game server's still running, isn't it? Let me stop the game server just to show a couple of things that I want to talk about. So let's run this game server. Let's open up the front end. run it in the debugger like I wanted to. And when we have those IDs, let me get back to the point I was making, and then we'll expand on it. So to get those IDs, we use this equation, this formula, in the homework handout code. So we use this formula, so you can actually reverse this as well. This formula guarantees that we're going to get unique IDs. You take the X location plus the Y location times the level width. That's going to guarantee a unique ID. But we can actually reverse this as well. So if you do have an ID and you want to go back to the XY, you could take the, divide it by the level width and take the floor of that division. That's going to be your Y. And then take the division, take the ID modulo the level width, and that's going to give you your X. So you can mathematically compute that as well if you want to reverse this thing. But let's get to what I want to talk about. I have a breakpoint right here at the end of level as graph. So we have this level as graph method, which maybe I'll go into Friday. I don't know. But we have this level as graph method, and we want to see what the structure is of that graph that we're going to get. Let's restart in the debugger. And I'm going to do it this way because I should get an error here that I want to show you. I got way too many times in the previous lecture when I wasn't trying to get it. But I should get an error, and of course I didn't get it at all. I'll try to get it later, but if not, let me just briefly talk about it. If you get a port already in use error when you're running the server, that means some other program on your machine is using that port 8080, which in almost every case ever is going to be you. You're the one using that port. And in most cases, when you're using the port, it's going to be a copy of your game server. So you run the game server and then you try to run it again. They're going to conflict. You can't run two of them on the same port. Or your previous game server didn't shut down gracefully and it's still using that port, still occupying that port. If you have that issue, the easiest solution is to just wait it out. You'll eventually get that port back unless you have two copies of the server running. But if you don't want to wait it out, you can change the port number. So if I want to, I'm already using 8080, so I changed it to 8081. And 8081 is also in use. I'm just going to change this to 8082 in the game server. And then also on the game view of the front end, I would change this to 8082 as well when I'm creating the socket connection in that first line. Now my server and my front end are going to communicate on 8082, and I get rid of that port already in use error. So if you're really in a jam where you can't tell why the port's already in use, just switch the port number. But you guys change it in two spots. Make sure you change it in both spots. If you don't remember where those spots are, go to Source, find in Files, 8082. It'll take you right to those two spots. All right, so we have this in the debugger. We're paused on the debugger. We're in level as graph, and we have a graph representing this level. The width and height is 19. And let's take a look at what this graph is going to be. Now, it's going to be the same structure as we just saw in the previous example, but of course, it's a lot bigger. We have a large game board here, which disappeared on me. There we go. It's fine. I think it disappeared because I changed the port number. But why didn't this one disappear? I'm not concerned. Let's just talk about this. As long as we have a game board to look at, that's all we need. It doesn't have to be active. But so the nodes are going to map each node ID to its corresponding node value. So let's pick one. Let's pick one a little tougher than that. So this node 42 has ID 42 and XY 4 and 2. And we can use that equation. We have a level width of 19. So 19 times 2 is going to give me 38. And then add 4, that gives me the 42. So 42 is this node at 4, 2, which is 1, 2, 3, 4, 1, 2. It's this node right here. So this is going to be node 42. And by the way, the way this formula works, it's going to be node 0, 1, 2, 3, all the way up to 19. All the way up to 18. And then 19, 20, 21, 22, 23, 24, 25, and then go left to right, up and down. That's what that equation gives us, is that numbering. So 42 is going to be 42. Now, if we look at our edges, our adjacency list, let's try to find 42 in here. 42, and I want to find the neighbors of 42. Now, I expect them to be this guy, and not this one because it's a wall. So if we look at this, we can look at the IDs, and this is where I am going to use the math to go backwards. I did have a reason to say that because you don't really have to do this in your code, but looking at these values in the debugger to figure out what the XY values are for these nodes, I'm going to run the math to get these IDs into XYs. So 42 I already found is this one because I looked at my nodes, but now one of the neighbors is 41. I expect that to be this one, but let's see. If I take 41, divide it by 19, and take the floor of that, that's going to give me 2. So I know I'm on row 2, 0, 1, 2. So I'm on this row. And then I'm going to take 41 and divide it modulo 19. Modulo is the remainder after dividing. So that's going to be 38 is the division, and then I have an extra 3 here. So the modulo 41 modulo 19 is going to give me 3. So 3, 0, 1, 2, 3, and it does give me this location right here. 23, that's going to be 1, 4, and then 61, I won't go through the math again. 61 is going to be, wait, I said that wrong. 4, 1, and 4, 3. So these 3 nodes are the neighbors of this node, and we get that information right here. From this node, these are going to be the neighbors of that node. Now, most of the time we don't have to, especially for task 3, we don't have to care about the correlation between grid locations and these IDs, except in 2 important spots, the start ID and the end ID. We need the IDs for those 2 grid locations. So for those 2 grid locations, we go to our formula and we compute x plus y times level width. Or if you don't even want to remember that formula, just call grid location to ID. Just say game state dot grid location to ID, start location, and then again with the end location. That'll give you the start and end IDs. And then you run breadth first search on this graph on those IDs while tracking distances, and then return the distance to the end node. Running breadth first search starting at the start node. So if I'm starting at node 42, I'm going to explore node 41, node 23, node 61, and then I'm going to explore the neighbors of those nodes, and then the neighbors of those nodes, and I'm going to slowly explore this entire graph. And each time I'm out of time. And each time we check the neighbors, checking, okay, has this neighbor been explored? If not, add it to the queue, mark it as explored, update the map of distances or paths. And yeah, I lost track of time there. Have a great day. I'll see you Friday.